Solve first order differential equations by integrating factor. Let's jump right into it. I am the DiffyQ man. First, I'm going to go through the proof for the solution by integrating factor. Then I'm going to give a couple of examples, one homogeneous, one non-homogeneous, and then I'm going to verify the answer using a TI-89. Okay. Here is a first order linear differential equations. Y prime plus py equals f. Here is the solution. Y equals e to the negative integral of p times the integral of f times e to the integral of p. We multiply both sides by the e to the integral of p, which from heretofore we will call the integrating factor. And here it is. We multiply the left-hand side by the integrating factor, and the right-hand side, this f, by the integrating factor. And here in this next step, the left-hand side changes, and the right-hand side, there's no change in the right-hand side. So in the left-hand side, I'm going to later show in a sidebar calculation that these two are equal. But I'll finish the proof first and then go back and do that. You integrate both sides, right? If you integrate the left-hand side is a derivative, right? So the integral of a derivative is whatever's inside the derivative. And then, so this is inside the derivative. The answer is whatever's inside the derivative is this. And on the right-hand side, you just add the integral here. I should have used parentheses here. Anyhow, and then the last step is just to isolate y by itself by bringing the integrating factor over to the other side. And here we have it, a QED. And here's the sidebar calculation I promised. The derivative of derivative of y times e to the integral of p. Here we just use the product rule, right? Derivative of the first term times the second term plus the derivative of the second term times the first term. And here we change the notation a little, change it up a little bit. Dy dx, we make it y prime, and then on the here for the what was the second term, we use the chain rule, e to the integrating factor times whatever's inside the integral, which is p, and then times the y right here. And then the last step is just to isolate the integrating factor, factor out the integrating factor. And here we just proved this is equal to this, hence that is equal to this. Okay, now let's go through some examples. Number one, dy dx minus 3y equals 0. Change the notation up a little bit, and then here's the solution. From here, you just plug and chug, right? Plug in p, which is negative 3. Plug it in here. Plug in f, which is 0. And plug in negative 3. I'll plug in p again, which is negative 3. And hence, you get y equals a constant times e to the 3. Non-homogeneous example, dy dx minus 3y equals 4. So here's the difference. Instead of 0, you have a 4 here. It's non-homogeneous. Y prime minus 3y equals 4. Changes. All we did here was change the notation a little bit. So this is the solution. Plug and chug again. Plug in the p. Plug in the f, which is 4. Plug in the p here again. And this one's a little. The calculus here is a little bit more complicated. Right, e to the negative 3 is e to the 3x, and you multiply by this integral right here. 4 times e to the negative 3x, and then here you expand the integral. Here you learned how to do this in Calc 2. So y equals e to the 3x. Here, the e to the 3x times e to the negative 3x is equal to e to the 0, which is 1. So 1 times negative 4 over 4 thirds is negative 4 is just negative. 1 times the negative 4 thirds is just negative 4 thirds plus the constant times e to the 3x. So here is your answer. Now let's verify using TI-89. Okay. The homogeneous one example first. Take a picture of. This is the formula to find the answer. Y prime minus 3y equals 0. X, comma, y. And the answer is y equals constant times e to the 3x, which is what we got. And on the top row, we have non-homogeneous. Y prime minus 3y equals 4. And the answer is y equals constant times e to the 3x minus 4 thirds. Well, the order here is kind of not the same as what we had in the equation in the PowerPoint, but that's it. So here we've been able to verify the answers. If you have any questions or don't understand anything, feel free to mention it in the comments. And I hope that helps, and have a nice day.